What do you do when you're trying to solve an equation like this and it's not on the unit circle? What do you do? Well, first of all, let me just prove to you it's not on the unit circle. You look at your unit circle. Let me find mine real quickly. You look at your unit circle and you're looking for everywhere that cosine is the square root of 3 over 3. And you can look all day and all night and you will not find it. It's not on there. So here's what we need to do. We're going to have to use a calculator for this. And so with our calculator, we will make sure that we are in whatever mode we need to be. I'm going to use degrees for this. I'm not going to do degrees and radians. I'm just going to do degrees. It makes it easier. So press mode. Make sure you're in degrees. And here we go. We're looking for the measurement of an angle. You've done this before. So the inverse cosine of the square root of 3, close your parentheses, over 3. And we have, let's round it off, we have a 55-degree angle. That seems easy enough. So, 55 degrees. Are we done? No, we're not. And here's the reason why. If the direction said to solve this for everything between 0 and 360 degrees, then we have more than one answer most of the time. So let's draw our unit circle. Doesn't have to be elaborate or pretty, but we're going to use it just to kind of prove a point. I can find a good marker here. There we go. Here's our unit circle. Here's the quadrants. There's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And a 55-degree angle is somewhere right here. Now, I haven't actually drawn the circle. I'm just going to sort of leave this up here for now without the actual circle on there. But 55 degrees is right about here somewhere. Well, that's in quadrant 1, but we have two answers, potentially. So we want to know everywhere that cosine would be, notice this, positive square root of 3 over 3. Positive. I wonder where cosine is positive. All right. Here's the kicker. This is the fun part. If we look on our unit circle, you'll see that everything is positive here in quadrant 1. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. Okay, let me kind of recap that real quickly. In quadrant 1, all of them are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. And sometimes you'll see calculus students or pre-calculus students scribbling this somewhere. A, S, T, C. And sometimes they say, all students take calculus. That's not true, but it's a good way to memorize it. All students take calculus. Yeah, it's a lie, but let's do it anyway. So what that means is we're looking for where cosine is positive, and that occurs here where they're all positive, and it also occurs here in quadrant 4. So I know that with two answers, I've already found one of them, but I have not yet found the other one that's right here. Remember when we did reference angles? This is where it comes in handy. I need to find the other angle, and you can sort of doodle this on your paper or in your head. I need to find the other place that cosine is positive. There's your first one. That's a 55-degree angle. And here's your other one. Well, this angle right here, this reference angle is 55 degrees. But if I wanted to really know the measurement of that angle, then I would go around like this. So what this is actually is going to be 360 minus 55 degrees. And whatever that is 305. So a 305-degree angle. And we just found everywhere, we've rounded it off, but we found everywhere that cosine is positive square root of 3 over 3. And that's what you do if it's not on the unit circle. I'm going to do several more. Let's keep going. I'm going to erase this. My board was all clean, then it gets all smudged. Oh well. That'll happen. I'm going to make up another one. Sine of theta equals positive 1/3. Okay, we're looking for everywhere that sine is positive 1/3. Before we even go any further, before we grab a calculator and type anything, let's think about what this means. I'm looking for where sine is positive. So in my head, I know this much. I know sine is positive here where they're all positive and here. So quadrant 1 and quadrant 2. I'm going to have two answers, and they're going to be here and here. One of the answers will be between 0 and 90 degrees. The other one will be between 90 and 180. So we grab a calculator. I'll show you what I'm typing, but you know what I'm typing. Inverse sine of 1/3, and I have a 19-degree angle. we have already found one of the two answers. So theta is 19 degrees. Knowing that theta is 19 degrees, that gives us an indication of how to find the other one. If this is a 19-degree angle, then this reference angle that we found earlier is also 19 degrees. But what that means is it's 19 degrees away from 180. It's 19 degrees less than 180. So we're going to do 180 minus 19 degrees, and it's going to give us our final answer, and our final answer is going to be 161 degrees. So 161 degrees. There we go. All right, let's do one that's tan. The one that's been out in the sun for a while. Okay, so let's suppose somebody said, find everywhere within one circle between 0 and 360 degrees that the tangent of theta is positive 2/7. Okay, well, before I go any further, here's what I notice. Tangent is positive in two places. It's positive here in quadrant 1, where they're all positive. It's positive here in quadrant 3. So I know I have an answer somewhere around in here and somewhere around in there. Most of the time, it will give me this one first. Most of the time. Okay, so I type inverse tan of 2/7, and I have a 16-degree angle. All right, so theta is 16 degrees. So I know that this is 16 degrees. Well, again, this is where reference angles come in handy. This is also 16 degrees. Well, if this is 16 degrees, it's 16 degrees away from 180. It's 16 degrees more than 180. And so this is what happens. You have 180 degrees, you add 16 to it, and you're going to get a 196-degree angle. And it makes sense if you swung this all the way around here. You have a 196-degree angle. There we go. We're going to do 3 more. We're going to do one with a negative on the sine, negative on the cosine, negative on the tangent. Yeah, I'll show you what we're doing. All right, so let's suppose somebody gives you another problem. And it says that, let's go in order, sine of theta is negative 2/5. Okay, clearly that's not on your unit circle. You look on your unit circle first, it's not on there. So we grab our calculator, we do an inverse sine of negative 2/5, and we have that right there. See it? Negative 24 degrees if we round it off. Negative 24 degrees. Okay. Now, I haven't written the actual directions up here, but the directions will say something like this. Solve for theta in between 360 and 0 degrees. Well, let's not do radians. Let's just stick with degrees. Okay, well, clearly that is not in between 0 and 360. So what we need to do is find out the two answers that are between 0 and 360, because that one is not the answer we're looking for. This is not the answer you're looking for. So even though this is an answer, it is not going to fit within the constraints of what our directions told us to do. So now we're looking for everywhere that sine is negative. All right, so let's draw a unit circle, at least in our head. Sine is negative. Ooh, not here. This is where it's positive. This tells me where they're positive. They're positive, see, plus sign, see, coordinate plane, plus sign. They're positive here and here. So sine is negative here and here. So I have two answers. One of them's there and one of them's there. And I'll go ahead and tell you that this angle right here is 24 degrees. Well, it was negative 24. Yeah, fine, whatever. Call it whatever you want to. But the distance from this angle to the x-axis is a 24-degree angle. Technically, it was negative 24, which implies the direction it turned, but its distance is 24 degrees. That 24-degree angle is going to be our reference angle. So this is also a 24-degree angle. If I wanted to know exactly what that angle is, it's 24 degrees less than 360. Here's your whole circle, but it didn't do that. It stopped here with 24 degrees left. Or it was 360 minus 24. So whatever 360 minus 24 degrees, that's what that is. So 360 minus 24 is 356. No, 336. Woo! Wow. Mental math there, Adam. 336. 336 degree angle. That's this one. We still have two answers to find. We have one answer left to find. We already found one, so let's find the other one. So we're going to find this one. 24 degrees more than 180, so 180 plus 24 gives me 204. So these are my real answers. Let's keep on going. Let's suppose I gave you the exact same problem, only it was cosine. Cosine gets tricky sometimes. Cosine of theta is negative 2/5. Okay, I'm looking for everywhere that cosine is negative, which tells me this. It won't be here. It will be here. It will be here. It won't be there. All right, so we grab our calculator and we start typing. Inverse cosine of negative 2/5. And we have 114 degrees. I have a 114 degree angle.
You're in class. I'll get out.
I'm filming something. What you need? Okay, so 5 minutes. 114 degree angle. That would be this one right here. That's 114 degrees. 114 degrees right there. So with 114 degrees, we need to figure out what the other one is. Now this is between 0 and 360, so yeah, we're good. We need to find out what this is. Should we find a reference angle? Not really necessary. Let me show you something. If this is 360 right here, we can just do that and go backwards. So do 360 minus 114, and it will give me my answer. 360 minus 114 is 246. So there we go. 246 degrees. We found both of them. 114 and 360 minus 114. Okay, let's do one more. Let's do a tangent that's negative. By this point, I think you're getting the hang of it, so let's go kind of fast. Making sure my math is right. Yeah, 246. Yeah, we're right. Okay, same problem, only it's going to be tangent this time. So the tangent of theta is negative 2/5. If the tangent of theta is negative 2/5, we type tangent, inverse tangent of negative 2/5, and we have a negative angle. Negative 22 degrees. Great. Actually, not great. It doesn't fall within our constraints. So, tangent is negative. Not here, but it is here and here. And we found that it's negative 22 degrees, which tells me this. A negative 22 degree angle would start here and go down 22. It would go clockwise 22 degrees. Thought it was negative. Yeah, fine, whatever. We're dealing with distance here. We're not going to worry about the sign when we're talking about reference angles. This is a 22 degree angle. Well, it's 22 degrees away from being a full circle. So we do 360 minus 22, and we get our first real answer, or our first answer that falls within our constraints, and we have a 338 degree angle. That is 338 degrees. So if I swung this all the way around here, it would be 338 degrees. Well, this is also 22 degrees right here. And it's 22 degrees less than 180, so here's 180, 22 less than that. So this measurement right here is going to be 180 minus 22, 158. Yeah, 158 degrees. There we go. And that is how you find them when they're not on the unit circle.